Today we're going to have a look at StarLogger and ArcGIS, Weed Management Simplified. And joining us to discuss how StarLogger enables weed management is Harley Schnagle. Now, Harley Schnagle is a highly experienced spatial ecologist and the director of TerraLab, where he leads groundbreaking initiatives in environmental monitoring and conservation technology. A published researcher with over 20 years of experience, Harley is not only the primary developer of StarLogger, but is deeply committed to biodiversity conservation. Good afternoon, Harley.
Good afternoon. Thanks for having me.
Now, I'm keen to find out more about Harley and his work, so I'm going to leave you in his very capable hands. Take it away, Harley.
Thank you, Alan, and welcome everyone. Today, I'm going to be talking through our StarLogger technology and how it can help simplify weed management. It simplifies data handling, speeds up data collection in the field, improves data quality and consistency, and seamlessly integrates into your GIS. There's a little bit of a session overview. I'm going to start with who TerraLab is and what we do, and then touch on the problem that we're solving, then go over the StarLogger solution, the hardware and the software side of it, and how it integrates with ArcGIS. And then I'll present 3 case studies from around Australia, displaying how other organizations are using the StarLogger and their integration with ArcGIS. And then we'll finish with some Q&A. First of all, TerraLab, we are a geospatial and ecological consultancy based in San Remo, Victoria, about an hour's drive southeast of Melbourne. We offer a range of ecological and GIS services listed on the screen, and we're the producers and the maintainers of the StarLogger system. Here's a list of recent innovation awards that we've received for the StarLogger solution. While I'm here, why not put that in there and plug that? But now we'll get into the mapping of weeds and the problem that our solution is solving. Ultimately, I believe the mapping of weeds shouldn't be optional. It's essential for projects, it's essential for securing funding, reporting to authorities, providing evidence for contracts and things like that. From a project management perspective, it's essential, but for field technicians in the field, it's often seen as a low priority, or at least the last thing they want to do. They just want to get out there and get their work done. That results in either absent data or low quality data coming back from the field. You can see a list of sectors up there where weed management is a significant part of their operations. Conservation and park management, forestry, energy, mining, water, asset management, all touch on aspects of weed management, whether it's for biodiversity conservation or even just assets and infrastructure maintenance. So here we are showing just 3 broad categories of weed monitoring or weed mapping. On the left, we've got the larger scale, the broader scale, remote sensing by satellites or whatnot. In the middle, you've got that sort of intermediate scale, drones or aeroplanes. And the final one, we've got ground-based mapping, and that's what we're discussing today. I just wanted to distinguish that we're not talking about a remote sensing solution or something like that. We're talking boots on the ground, high resolution data of exactly what's happening meter by meter. So this is a little bit of a representation of one of the issues that the StarLogger solution solves, and that is where you have if you present the 3 different field operators with the same weed infestation, you can end up getting 3 different sets of results based on the operator's protocols, their enthusiasm for the job, the time they have, all those sorts of details. And in a polygon setting, you can get other results like this as well. Different forms of mapping can suit different projects, but all things being equal, 3 different operators will produce 3 different sets of results. These different mapping protocols, I guess you could call them, produce different metrics. They produce different mapping outputs, and they take varying lengths of time to collect. The StarLogger solution is a hardware and software solution that automatically collects the data while the field technicians are going about their work in the field. You can see it's an attachment that goes on the back of a spraying device, pictured here as a backpack spraying device, but it also suits a range of other land management tools that we'll touch on later. This one here, that part there is the brains of the setup. It's got an LCD display and onboard storage. And essentially, it's designed to be simple to use. There's no on-off switch. What we like to say is you clip it on and forget it's there. You just put it on and go about your work. It'll turn on when you start working. It'll turn off when you're done, that sort of thing. The part that goes to the handle is the trigger mechanism. It's tailored for different handles. Has a three-way selector switch on there for categorizing weeds. But the important distinction to make is it's not a flow meter, it's a data logger. Our opinion is that it's trivial to know how much herbicide was applied to each individual plant. What's important is the location, the date, time, the event, and that sort of thing. Here's just a selection of some of the other devices that the StarLogger is compatible with. You can see that it suits backpack sprayers, high volume sprayers, UTVs, ATVs, tree planting tools, but it can also be customized to work on boom sprayers or with cut and paint hardware and other applications. So here we've got the video from our website. I know it's a little bit of a promo video, but the whole idea is I just wanted to, it walks through the process pretty well here. So you collect data in the field, you're categorizing as you're spraying, and when you plug it in to upload at the end of the day, it triggers it to send the data through your organization's Wi-Fi, where it's processed and displayed in a web application. You only need one device for different bits of hardware. So you would need one StarLogger. You can put it on a backpack one day, and then a high volume sprayer the next day, then a tree planter the next day. But once the data is uploaded into the account, it integrates seamlessly with other tools like ArcGIS Pro, field maps, or you can create your other tools, your own other tools like dashboards, web applications, and that sort of thing. Here we'll go over the data pipeline, a little bit of how it works. So starting with the field data collection, I already touched on that, but you collect data in the field, it gets stored on the device while you're working. It transmits the data to our servers for processing, where it's converted into spatial data. The spatial data, there are three layers that each device produces. The first, one is points, one is lines, one is polygons. The point data is equivalent to the raw data. It's pretty much how it comes out of the device, and it's got all the metrics about how many satellites it had in view, what the battery percentage was, and details like that, whether the trigger was being pressed. The line layer is the track log, which is where the operator was walking while the device was turned on and active, whether they were spraying or not. And the polygon layer is the spray zones. The spray zones are an estimated projection of the footprint of herbicide applied to the ground. That varies based on the duration of the spray and whether they were moving and things like that. So the size and scale of those spray zones varies. Next, it is made available in ArcGIS Online. And by default, the standard customer of the StarLogger views the data through an Experience Builder application on the web. But if your organization has greater GIS capabilities, because it's hosted in ArcGIS Online, you can integrate it into ArcGIS Pro, your own dashboard products, field maps, use the API, synchronize to your servers, anything you need to do. This is an overview of the web application in action. This is our old version using Web App Builder. This is for a site where prep spraying was done ahead of carbon sequestration planting, hence why it's done in organised rows. Nevertheless, you get a fair overview or a good representation of what the data looks like. Being demonstrated now is the time slider tool, so filtering by date essentially. You can see at the bottom of the screen the cursor dragging the bookmark ends throughout a date range to isolate different parts of the data. There's the attribute table bringing out details of the data and a selection being applied. From here, the user can export data into CSV format, pass it on to a client or something like that if they want to know where the spray zones, where the spraying occurred, where the trigger was being pulled, and details like that. Here is that same data in ArcGIS Pro, where a few more analytical tools become available. Here's a graph of the spray areas. You can interact with it a little bit more detail. We've applied a heat map here. Because this is a planting prep job, it's probably not the best representation, but you can imagine how powerful that heat mapping would be in a weed control setting with different densities of weeds. Now the data is turning on the point layer. You can see the points at 1 point per second there. So it's quite hefty and quite useful for analysis. And here's a representation of the data in the new Experience Builder application. On the right-hand side, you can see the reporting form that leverages Survey 123, and currently it's held on the environmental conditions section, but there's a whole lot of metrics that you can input there about your project, what you were doing, what herbicides you were using, what weeds you were spraying, which makes your data, enriches your spray zone data. So now I'll go through the case studies. The first one I wanted to talk about was Phillip Island Nature Parks. Those of you who know Victoria know that where I am based in San Remo is just across the bridge from Phillip Island, so I'm a little bit biased in the selection of nature parks here. Phillip Island Nature Parks are the Crown land managers for DECA on Phillip Island. They manage 1,800 hectares, or approximately that, and you may recognise the ecotourism operations that have potentially the Penguin Parade. Those ecotourism venues fund the Crown land management activities that they undertake, and their rangers and their contractors use the star logger on Phillip Island. Phillip Island Nature Parks have always used ArcGIS-based mobility solutions. On the left, you can see their field maps, a screenshot of field maps showing polygon representation of their weed control efforts. And on the middle and the right, you can see star logger data in field maps with other weed mapping data in the application as well. The first thing you'll notice is the resolution of the star logger data being the next level down from that broad polygon reporting. The mobile data integrates directly into their dashboard that they can use for reporting and tracking their weed management activities displayed there. And here's a representation of what I was mentioning at the onset of the presentation, where the polygons may not match exactly what happened on the ground. So you can see the green polygons are what was mapped, assumed what was done in the field, and the blue lines are the star logger data from that same day. So you can see there's a little bit of a mismatch. Now I cherry picked this. It's not a standard representation, but this is just to prove the point about the mismatch between polygon reporting versus high resolution data like this. So nature parks use the web application for viewing and editing on the desktop. They integrate it into field maps so supervisors can pick up where they left off from day to day, and use dashboards for obtaining metrics on the area sprayed and comparing temporally from year to year. The next case study is Gippsland Water. They manage over 10,000 hectares of land, and with a tenure that large, GIS is essential both for the land management and also, because they manage quite a complex water network. Here's a representation of their data in the Experience Builder application, showing star logger data in an agricultural zone adjacent to a conservation zone. The functionality I wanted to highlight for Gippsland Water was the contractor integration. So on the left, we have a representation of the contractor's data. In the middle, we have a rectangle, generalized rectangle representing the client's site. In this case, Gippsland Water's site would be the rectangle. And on the right, we have a representation of what Gippsland Water would see of the contractor's data. So there is a geofencing of the contractor's data based on the extent of Gippsland Water's tenure. So the contractor is free to use the star logger on other sites with a live clip of it going out to Gippsland Water for reviewing or reporting. Gippsland Water have around about 900 hectares of land managed under landowner agreements. With landowner agreements, there's certain commitments that the landowner must make, and they must report those back to the authorities. And the star logger data has been used in the past to demonstrate compliance with these requirements. So they had a requirement to conduct certain amounts of weed control on certain sites, and star logger data was the evidence for that work. So here we've got a dashboard representation showing the dynamic nature of the metrics. It's not Gippsland Water site, but you can see here that the metrics are all updating based on the map frame view. The metrics that can be displayed, there's quite a lot more that you could use. Now you can see the selector switch metrics for each individual weed from the selector switch on the handle. There's the data over time in the graph that just got filtered down a little bit. And in the top right, there's also date filtering. And the final case study is AW Landscape Board from South Australia. Their area that they manage covers 250,000 kilometres squared, which is absolutely huge. You can see it in the map there, covering a significant part of South Australia. It includes 340 kilometres of coastline as well down the south there, but predominantly focused around the northwest area. And they've had a buffelgrass program going for the last 15 years, controlling buffelgrass. You can see here a couple of operational plans and strategies focused around managing it in their district. They previously used traditional mapping workflows, but reported that slowed progress from the field operators having to stop and do the mapping at each spray event, and also resulted in data gaps purely because of human error, I would imagine. It can happen when you're out there focused on what you need to do, and then you forget those little bits of reporting that may be required. So they took up the star logger as a more seamless way of reporting what they were doing as they were working. They have created their own dashboards, and you can see here quite a comprehensive one showing all their data across their region, and the metrics of total coverage per year. The inset on the top right is just a zoom. It's not part of the dashboard. It's just a zoom in showing what the spray zones look like when you do zoom in. But like the example I showed before, this is just a still image, but like the example I showed before, the dashboard is dynamic to update the metrics as you move around the map frame. And you can see here in the dashboard that the top right element turned red as I zoomed in on this part, showing that it's got conditional formatting to show that this particular area that they zoomed in are actually increased in cover from one period to the next, which is, really powerful for, evaluating how your project's going if you need to look at certain extents. They have an integrated Python workflow to produce a site status dashboard, shown here. It might be a little bit small, hopefully you can see it, but you can see that the colors represent sort of a summary on what each site, where it's at. So, whether a site's been treated or hasn't been treated yet, whether it's a new site, or whether it's been inspected but there hasn't been any found, which is also, absence of weeds and reducing the scouting effort is a pretty useful metric as well. And finally, I just wanted to highlight that we use the dashboards for monitoring the StarLogger performance of our own internal system. It's obviously blurred out for privacy here, but it's all annotated, showing what the metrics display. So it shows in the top left, it shows a map where uploads are happening across the world from the device, the number of uploads in the last 24 hours or 7 days, processing times, so we can see if issues are creeping in. There's error alerts if there's processing errors, and data quantity over time. It's pretty important to understand as well, so we can scale for peak demand. So in the future, we plan to continue to offer over-the-air updates to the hardware and to the software solution. And in the future, we also hope to offer new hardware with improved ergonomics, the opportunity to have higher accuracy, down to the centimeter level, and potentially even an accelerometer for automatic detection of tree planting activities. Finally, I just want to acknowledge those who contributed content to this presentation: Ben Thomas from Nature Parks, Shannon Dwyer from Gippsland Water, and Adam Wood from AW Landscape Board. If you need more information, you can get to the website from the QR code. There's our website there, starlogger.com. There's no .au, just starlogger.com.
Thank you so much, Harley. That was amazing. I personally love how simple the device is to use, and that it's not actually getting in the way of an end user's standard workflow, which can sometimes be a barrier to entry when you're trying to introduce data capture into an existing workflow. So that is fantastic. And I'm also loving how simple it is to use that data from StarLogger alongside your other organizational data through ArcGIS. Superb. Thank you so much. So now it's time to jump into some Q&A, and we have had some questions come in during the presentation, which is fabulous. So we've got a question here from Carol, and Carol says, would being able to monitor flow enable the logger to support quality control for field supervisors and contract managers to ensure that best practice is being adhered?
It doesn't monitor flow. Like I mentioned, we intentionally left that out of the design because we decided that it was more of an agricultural need rather than a conservation need. But I do understand there are reporting commitments from herbicide users, which is why our reporting system that I showed, the panel on the left-hand side, allows you to add in herbicide metrics if you need them in the system to record them, fulfilling your reporting requirements. But it doesn't tell you, that 30 mils was sprayed on this thistle and 35 on that thistle or anything like that, which, like I mentioned, we thought would be trivial to know.
Great, thank you for that, Harley. Got another question here from Anne, and Anne has asked, how long does the battery typically last?
From what one of the things we wanted to make sure was that it covered a full day's work, obviously. I was also pretty keen to make sure it covered 2 days' work in case somebody forgot to charge it. Obviously, the goal is that you charge it every day, but it should last 2 days without a charge, and I've seen it quite commonly last into the third day pretty comfortably as well. So, yeah, it'll get you through plenty, but yeah, definitely still charge it every day. That's also how the uploads happen, but it'll last a long time.
Oh, that's fantastic, Harley, because I know I've personally forgotten to, I've come back into the office after doing some field work and forgotten to put my tablet on charge or something like that. And it's such a pain coming in the next day and going, darn.
Or even the
So,
PowerPoint was turned off.
yeah, that has happened too before, believe me. So that's really great. But I guess if you're just working it in as part of your workflow, so you come back into the office and you plug it in to charge and to also, like you said, upload that data. If you're working that into your day-to-day workflow, it should be fairly easy to remember that procedure. That's great that it does
100%.
last that extra time just in case, though. All right, so if we move on to our next question. So Carl has said that he's not very tech savvy, so he does like the simplicity of the device, but he's got some questions just around the data. Does he need someone in his organization to manage any of that mapping, or is that fairly automatic?
Um, I mean, the whole system was designed to be simple to use for the operator. So yeah, it is. It's entirely automatic. If you have the device on the backpack plugged in, it'll be recording. You take it off, you plug it in to charge, it'll upload, and that's all you need to do. You open your browser, and the data's there after processing, after a little bit of a lag from processing time. In terms of actually reviewing the data, the tools work. Scroll into the area you worked, you'll see the data, and it depends how sophisticated you want to get with your analysis. You can print maps directly from the web application. You can look at the attribute table and scan through the data, the raw data, and export that if you need to. And yeah, you can get more complex from there, but the basic user doesn't need anything more than just the ability to use the browser and pan around a map.
Fabulous. That's really great to hear. So we've just had another question come in through the chat from Matt. Matt has asked, how heavy is the unit and can it increase fatigue when attached to the handle of a high volume sprayer?
Yeah, that's a good question. I get that all the time. It's 250 grams, about that. And yeah, I mean, it's more the handheld devices themselves, the sprayers, are a fair bit more than that, plus the weight of the hose and the trumpet and all that sort of thing. So it's only a small incremental weight increase for the user. But any increase of weight is going to be noticeable to the field technicians. They use these devices every day, so if you increase the weight by 10 grams, they would know. So yeah, 250 grams. It's not heavy, but it will be noticeable after 8 hours of use, for sure.
I guess at the same time though, as you're spraying, you're decreasing the weight in your backpack potentially because you've got less liquid in there because you've applied that to the weeds. So,
Yeah, yeah, for
I guess
sure.
I
And
guess there's
on the
that to
backpack,
consider as well.
yeah, I mean the backpacks are a whole different game. They've got 10 to 15 liters in there, so there's 10 to 15 kilograms just in herbicide weight as well. So you definitely wouldn't notice it on a backpack, but in the handgun situation with a high volume sprayer, um, I'm sure it would be noticeable. It's not much, but like I said, it would be noticeable. But it's improving other efficiency parts of the workflow as well. The user's not having to pull out a mobile phone, take off their spraying gloves to, input data or something like that, or, whip out a Garmin or something, and punch in numbers there. So if they needed an extra rest or something like that because of the fatigue, I'm sure it would be far more offset by the improvement of efficiency in the mapping for sure.
Absolutely. Now, Libby's just asked a question, and it would be good to clarify this point here. So she said, just wondering how the device works when there's no internet or provider service in remote areas.
Yeah, that's a really good question too. The device, excuse me, the device itself doesn't require mobile phone coverage. It doesn't require Wi-Fi or anything like that when it's in use. The data is collected and stored on the device as the operator is working. The only time it's transmitted is when you come back to the office and you plug it into charge, and then it uploads the data from there. If you wanted to review the data while you're in the field, field maps, like if you created your own field map tool, field maps has the ability to make data available offline. So when you are deploying and going out into that mobile denied area, you can synchronize your map. So all the latest data is synchronized onto your phone, and you can go into that mobile denied area and still open it up and see all the data. And yeah, get the latest StarLogger data updates that way. But in terms of operating the device in the field, you don't need any of that. It's all stored on board the device.
Fabulous. Another question here from Dalipa. Are we able to collect spray data automatically, e.g. via webhooks?
I think I need more information about what's required there, and what sort of webhooks would be required. Yeah, and you might need a little bit more information about that.
Yeah, that might be one that we can take offline for you, Dalipa. So if you're willing to sort of use your post-event survey to provide a little bit more information for us there, that would be great. Thank you. Okay, look, I think we've got time for one more question, and this one's going to come from me, Harley. What's next for StarLogger? So we know that you've just moved from ArcGIS Web App Builder to the new ArcGIS Experience Builder for those web viewing requirements. What are you hoping to do next with ArcGIS?
Right now we're focusing on hardware improvements, but we're always monitoring Esri's product releases to see if any of them would offer value to the StarLogger system, and if they did, we're pretty eager to integrate them into the platform where we can. But so right now it's predominantly focused around software improvements for the end user, but and hardware improvements, but nothing imminent per se right now.
Lovely. Oh, do you know what? I think we've got time for one more. And again, this one's from me. So I'm just curious, how long did it take you to actually develop this product? So from the time you had that initial spark of idea through to the actual fruition of having StarLogger in your hands?
The idea is, the concept is, from my perspective, is decades old. I sprayed weeds early in my career when I was going through uni and things like that. And I thought there must be a better way to report data back, because at the time there was no data going back. But the technology wasn't really there for that kind of system at the time. But then once I decided to have a crack at it with my colleague Keen, he helped me develop it, and it was actually a pretty quick process, largely because of his expertise. So from initial discussions to prototype was probably 6 months to a year, and then just working out the software at the end of it, the web application after that. So relatively quickly in the end.
That's incredible. Like, I just look at this sort of thing and think that, gee, that must have taken you years and years and years, but that is fantastic. Okay,
it rolled around in the brain for a while.
Yeah, that's it. It takes a while to get from brain to paper, so to speak. But no, that's wonderful. You've done such a great job. So look, that's all we have time for today. So thank you everyone for your questions, and big thank you, Harley, for your time here today. That was fabulous.
Thank you. Thanks for your time, everyone.